as we start out today, it's going to be just like yesterday. We're going to use the same thought process. Get the equation set equal to 0. Get that equation set equal to 0. Factor it to, you remember that? No, rename it. Give it its factored name, in other words. So you're just replacing the trinomial with its factored name, and then you use the zero product property to solve. Set each of the factors equal to 0, solve for x. Okay? Well, so that's nothing new. That's what we did yesterday also. But now a is not equal to 1 today. I say to you, it's really a good idea to try to get a to be a positive number. It actually should make life a little easier. So it doesn't matter which side the zero's on. The 0 can be on the left side, the 0 can be on the right side. We just want to try and focus on a being positive, not moving that if we don't need to, or move it if we do need to. So we're going to move the negative 3x squared, because then it's on the other side, it will be a positive 3. So we have 0 on our left side of our equation. Let's put that in standard form right away. What would that look like in standard form?
3x squared minus 4x plus 1.
Okay, 3x squared minus 4x plus 1. Okay, what's our a value?
3.
3. Our b?
Negative 4.
And c.
1.
Okay. What's different from yesterday now that a isn't equal to 1? What do we have to do in our diamond?
A times
We're going to take a times c. So what is our number going to be?
3.
3. 3 times 1, this is going to be a 3, and they have to add up to negative 4. So what multiplies to 3 adds up to negative 4? Negative 3, negative 1. Now, yesterday we'd have been ready to set up our factors, but we're not today. Even though many of you tried this in chapter 7, and then it cost you points on the assessment because you would have said right now, oh, it's x minus 3 times x minus 1. Would that FOIL back out to 3x squared minus 4x plus 1? If you said right now that this is x minus 3, x minus 1, and moved on, would that FOIL back to 3x squared?
No.
No way. This would FOIL back to x squared minus 4x plus 3. That's not what we have. So what do those numbers really become? Negative 3x plus negative 1x. Because those are going to replace our negative 4x in our trinomial, aren't they? So now we'll go down and rename our trinomial as a 4-term polynomial. The only thing that got changed in our trinomial, the negative 4x got replaced by the negative 3x and the negative 1x. And now we're going to factor by grouping. We have our 4 terms, 2 groups. What should we call the GCF of the first group?
3x.
3x, okay. And there's, oh, by the way, there's our 0 equals is still out front there. We haven't really gotten rid of it. So 3x is going to come out of the first 2 terms. What will the resulting factor be?
X minus 1.
X
Minus.
plus a negative 1, right? Okay. We'll clean it up later. Negative 3x divided by 3x, that's negative 1. Then plus, what's the GCF of the second group?
1.
If we GCF out of 1, won't we have a negative x at the beginning? And we want a positive x, so what should we factor out instead? Let's do a negative 1. Because then we'll have x plus 1 divided by negative 1, negative 1. Now those factors match like we need them to. We need these guys, the x plus negative 1 to match. So that now we can say, bring down our 0 equals, we have the factor name would be our greatest common factor of the whole 4-term polynomial, x plus negative 1. What's our other factor going to be?
3x plus negative 1.
3x plus negative 1. And then in this next one, since we have room here, I'm going to clean it up. X minus 1 times 3x minus 1. Okay, so we've renamed it. Last thing to do, set each factor equal to 0. Use the, what property were you using?
No.
Zero product property that says set each of them equal to 0. X minus 1, no, we set each factor equal to 0. We have a nice linear equation twice, and we solve for x. Over here we add 1. Oh, looky there. There's that one solution we said we could see on the graphing calculator, and it was in the table, wasn't it? Well, then what's the other one? And one we couldn't see in the table and couldn't tell for sure on the calculator. And we're going to divide both sides by 3, and x is going to equal 1/3.
That's usually 3. That's 6.
Pardon? Right, we were going by halves on the delta scale of our graphing calculator, not by thirds. So if we would have been going by 1/3, then we would have been able to tell exactly where it was crossing. Okay? So turn your calculator on, and we'll see if you agree now. Do you think it looks like it's crossing at about 1/3?
Yeah.
Remember we did a zoom 4 if it went back to the original window. To get a little bit better window, we did a zoom 4. What do you think?
Yeah.
I remember hearing a quarter, a third. Some of us said a half, and then we said, well, no, well, that we already checked out on the table, that didn't work. So see how sometimes the graphing is not a very reliable way for us to get the solutions, is it? So we have to have other methods for being able to solve them also. Okay, so anybody got any questions about this? Okay, you go to the back side now. I'm going to solve the last one. You're going to solve the last one. We're going to see if we come up with the same answers. I'm at the diving part, and if you're getting stuck, you can look up, but try to work on your own. Sure, good thing we don't have a factor in that last chapter. And after you have your solution or solutions, go ahead and put it in the graphic calculator and verify. See if you agree, or the calculator agrees with you, maybe is the thing to say. How many solutions did you get? It's repetitive, isn't it? Even though the factors weren't the same, they still got the same solution. How'd that work? Yeah, it is the same answer, but I thought the only way we got one solution is if both factors were the same. And didn't I also tell you that something, when we were talking over here, I said, oh, when you have a perfect square trinomial, you will get one solution.
Yes.
So let's go back up here to this right here. I'm going to put a red arrow by, this is our trinomial, after we had it set equal to 0, right? Is that a perfect square trinomial?
Yes.
No way, 18 is not a perfect square, nor is 2. That's not even possible to be a perfect square trinomial. So how in the world did this end up with, or did I just lie to you when I said, you will get one solution when it's a perfect square trinomial? What else is the very last thing we learned in chapter 7 with factoring, when we said to factor it completely? What did we say? What's the first thing we're always going to look for?
Square root.
A GCF? Does that have a GCF?
Yes.
Oh, what is it? 2. So in other words, this could be renamed as 2 times what?
X
Squared minus 6x plus 9. How you feeling about that? You think that x squared minus 6x plus 9 might be a perfect square trinomial? Yeah, what would its factors be? X minus 3 times x minus 3. Yeah? And then when we set that equal to 0, what do we get? We get x equals 3. And why didn't we have to worry about this? Because it doesn't have any x's with it.
Nope.
So if it doesn't have any x's with it, we don't have to set that factor equal to 0 and solve it. It only has to have an x. So we got the same answer, so that's why I didn't lie to you. It's just we didn't GCF it first, did we? That's the reason. So we have one solution. Did the graphing calculator verify it? In other words, if there's only one solution, what's true about the graph again? That is the
Vertex.
vertex. That is the vertex, isn't it? Okay. This is the kind of stuff you're adding on to your homework today. When A is not equal to 1, that's what we need to do. Okay? Anybody have questions?